Today, I'm talking about antiderivative. Antiderivative is similar to integration, which will be studied in next chapter 4. We consider the function fx and derivative of fx. This is a differentiation. Differentiation of fx is f prime x. This is a gx is the derivative of fx. And we consider if we consider fx and derivative of large fx is fx, and this large fx is called antiderivative of small fx, antiderivative. So the function large f is called an antiderivative of small f on interval I if f large f prime x is small fx for x on I. General antiderivative of small f is fx plus the constant. So I will take an example. It means the antiderivative of fx is large fx plus 1, large fx plus 2, and many functions can be antiderivative of small fx. So I will take an example. First example is find antiderivative of sine x. It means large f prime x is sine x. So our purpose is to find this fx. The prime is sine x. So we have already known derivative of cosine x is minus sine x. So this fx can be minus cosine. This is minus cosine x. So antiderivative of sine x is minus cosine x plus c. This is the answer. The second question is f prime x equal xn. Our purpose is to find f of x. S prime is xn. So this right hand side function is power function. So left side function must be power function. So we have already known xn prime is nx to the power of n minus 1. So now at this case, right hand side must be xn. So in order to become xn in the right hand side, this function shall be xn plus 1. And xn plus 1 prime is 1 over n plus 1 xn. So we have find xn, but we eliminate this term. So eliminate this term. Now this is n plus 1. So 1 over n plus 1 is have to be multiplied to cancel this term. So this is antiderivative. So antiderivative x to the power of n is 1 over n plus 1 x to the power of n plus 1. So third question is f prime x equal x to the power of minus 3. And we apply the question to formula. So this is 1 over n. At this time n is minus 3. So minus 3 plus 1 x minus 3 minus 1 prime is x to the power of minus 3. So antiderivative is minus 1 over 2 minus x to the power of 2. No, this is plus 1 x to the power of minus 2 plus c. This is the answer. It means minus 1 over 2x squared plus c. This is the antiderivative of x to the power of minus 3. So we have to know the simple antiderivative differentiation. It means antiderivative formulas. So this is function, and this is antiderivative. Antiderivative, and this is first function is This is first function. Function is constant multiply the function, the antiderivative, and c large fx. We assume fx is antiderivative of small fx, and large gx is antiderivative of small gx. So this is the first formula. The second formula is a small fx plus large gx. The antiderivative for this function is large fx plus large gx. This is the linearity. Linearity is satisfied. And third function is x to the power of n, and x is not minus 1. At this time, 1 over n plus 1, x to the power of n plus 1, plus c. This is the antiderivative. And c and c1 is constant. Number 4 is cosine x. The function is cosine x is an antiderivative of cosine x is sine x plus c. And derivative for sine x plus c is cosine x. Derivative of 1 over n plus 1 x to the power of n plus 1 plus c is xn. The 5 is, this relation is antiderivative. And this relation is derivative. 5 is function sine x. The antiderivative of sine x is minus cosine x plus c. Because minus cosine derivative of minus cosine x plus c is sine x, so this function is antiderivative of sine x. So next is sec square x. Its antiderivative is tangent x plus c. Next is sec x tangent x. The antiderivative is sec x plus c, and so on. So this is a simple anti-differentiation formula. Next example is find z such that g prime is the antiderivative of g is this. This is the plus c is omitted. So g is 4, and antiderivative of, so this is large gx, this is hx and a gx. So antiderivative g prime g is 4 gx plus hx. So antiderivative of small gx is large hx, so this 4, and this is antiderivative of minus cosine x is sine x, plus this is 2x to the power of 4 minus 2x power of 4 minus, this is x to the power of 1 over 2 minus x to the minus 1 over 2. So this is a antiderivative of some function. The some function is x to the power of 4, 2 multiply 4 plus 1, 1x, 4 plus 1, minus minus 1 over 2 plus 1 over 1, x, 1 minus 1 over 2 plus this is original function, so this is minus 4 plus c and minus 4 cosine x. So cosine x plus 2 over 5 x to the power of 5 plus 2 square root x plus c. Right? So this is antiderivative of the large gx. The next example is find f if f prime x x square root x and x1 equal to. this is a fx. This is a f is antiderivative of f prime x. So f prime x, x to the power of 3 over 2. The antiderivative of f prime x is 1 plus 3 over 2 over 1 x 3 over 2 plus 1 plus c. So this is 2 over 5 x 5 over 2, right, plus c. And initial point is not initial point. This is some condition is f1 is 2 over 5 multiply 1 to the power of 5 over 2 plus c equal to. So this is 1. And c is 6 over 3 minus the 2 minus 2 over 5 and 10 minus 2 over 5. So 8 over 5. The answer is f is this is 2 over 5 x 5 over 2 x 5 over 2 plus 8 over 5. This is 2 over 5 x square root x plus 8 over 5. This is answer. The find f if 2 antiderivative is 12x squared plus 6x minus 4, and we have two conditions. So first we find f prime x. F prime is antiderivative of f2 prime x, and 12 multiply 1 plus 2 over 1 x 2 plus 1 plus 6. This is 1 plus 1 over 1 x 1 plus 1 minus 4x plus c. So it can be this is 4 x to x cubic plus 3 x squared minus 4x plus c1. And f is antiderivative f prime. It's 4 multiply 3 plus 1 x to the power of 3 plus 1 plus 3 multiply 1 over 1 plus 2 multiply x 2 plus 1 minus 4 multiply 1 over 1 plus 1 x 1 plus 1 plus c1 x plus c2. This is f. So f is x to the power of 4 plus x to the power of 3 and minus 2x squared minus plus c1x plus c2. We have two conditions. Based on these two conditions, we can find c1 and c2. f0, versus f0 is 0 to the power of 4 plus 0 to the power of 3 plus minus 2, 0 squared plus c1 multiply 0 plus c2 equal 4. So c2 equal 4. So f1 is 1 to the power of 4, 1 to the power of 3 minus 2 multiply 1 to the power of power square. c1 multiply 1 plus c2 is 4 equal 1. So this 1, 2, this is cancelled, and this is c1 plus 4 equal 1. So c1 is minus 3. The two antiderivative, f is x to the power of 4 plus x to the power of 3 minus 2x squared minus 3x plus 4. This is the answer. So next question is, make a rough sketch of antiderivative fx f0 equal to given below fx curve. The fx curve is given. Fx is like this. This is x and fx. Fx is f prime x. And this is like this. This is like this. Inflection point, this is 0 and we are draw again. Yeah, this is 1. This is 0 and this is 1. This is 2. This is 3. And this is 4. And this is 5. So we draw large fx. Large fx is antiderivative of small fx. This is large fx. When x equals 0, the function value at x equals 0 and 2, this 2. And this is 0. 0 means when x equals 0 means f prime x0. But x0 is this can be local maximum, local minimum, or inflection point. And 0 point at this point and this point. At this region, f prime x negative. This is a decreasing function. Decreasing function. And sign changes from negative to positive. Negative to positive. Those when at x equals 1, fx has local minimum. And it's positive. From x equals 1 to 3, the large fx is increasing function. And x equals 3. This sign is changed from positive to negative. So at x equals 3, fx has local maximum. And like this. And x equals 3, this is a decreasing function, and this is decreasing function. This is the function of fx. Correct? Function of fx is, and this is an infinity. X is approaching infinity. The fx is approaching 0. Approaching 0 means this is 0 means like this. I don't know this or don't know. This is we don't know, but the shape of large fx graph like this. So next example is a particle moves in a straight line, one-dimensional line. Straight line, and at is acceleration is 6t plus 4, and v0, the velocity at initial point is minus 6 centimeter per second. It means the particle is moving left in the direction of left side, and displacement initial point is 9 centimeter, and it means 0 in initial point is minus 9, and firstly the velocity is negative, is particle is moving in this direction. So firstly we find displacement at t. Displacement at t is now the acceleration is given. Acceleration is v prime t and 6t plus 4, and this is given. And our purpose is to find displacement, and we already have to f prime t equal vt. So in order to find displacement, firstly we have to find the velocity. Velocity is antiderivative of acceleration. So this 6 multiply. This is 2 plus 1 t square plus 4t plus c1. This is the velocity. And 2t square plus 4t plus c1. So s prime t equal 2t square plus 4t plus c1. So displacement is antiderivative of velocity. So st equal 2 multiply 2 plus 1 over 1. This is 2 square. t is, I'm sorry, this is 1. 1 is 3. And this 3 multiply t cubic plus 4 multiply 1 over 1 plus 1 t square plus c1t plus c2. So displacement is, displacement st is t cubic plus 2t square and plus c1t plus c2. The given condition is v and s. The v0 is, this v0 is c1. c1 is minus 6. Minus 6, so it can be t cubic plus 2t square minus 6t plus c2. The second condition is s0 equals 9. s0 equals c2 equals 9. So displacement at time t is t cubic plus 2t square minus 6t plus 9, unit is centimeter. This is the answer. The next question is, the ball is thrown upward with a speed 15 meters per second from top of building. The building, we have the building. This building and top of building, we throw the ball upward. So this is v0 is 15 meters per second. And 130 meters above the building. This is 130 meters. 30 meters, find its height above the ground. This is the height. Ground after t seconds. So we try to find ht, find the maximum height and when does it hit the ground. Firstly, we have the height after t seconds. This is ht. And ht, we have the acceleration is 9.8 meter per second square. So have a is g. This is v prime. It's 9.8. The v velocity is antiderivative of acceleration. The v is 9.8 t plus c1. C1. The v0 is c1 is 15. So vt equal minus 9.8 t plus 15. The s prime is v. The first question. So s is antiderivative of velocity. So st is minus 9.8 multiply 1 over 1 plus 1 t square plus 15t plus c2, and it can be minus 4.9 t square plus 15t plus c2. So S0 is, this is S0 is 130 meter. The S0 is 130, so ST is 4.9 t square minus t square plus 15t plus 13 meter. This is displacement. The second question is, the first question and second question find the maximum height. In order to find the maximum value, we have to find the derivative of it's h, not h prime. H prime t is my 9.8 t plus 15 equals 0, and t equal 15 over 9.8 seconds. So h2 prime t is minus 9.8 is negative. The shape of ht is concave down. This t is 15 over 9.8. So this point is local maximum. This is when t is 15 over 9.8 seconds, ht is maximum value. So the maximum value is h 15 over 9.8. This is the maximum height at t when t is 15 over 9.8. The third question is, when does it hit ground? Hit ground means the time we have the time when h equals 0. So it means h equals 0 means this is 0. 4.9 t squared plus 15t plus 130 is 0. When ht equals 0, we have to find the t. The t is 15 plus minus square root of 2,773 over 9.8. So we cannot take a minus sign because we cannot minus sign. The time become minus, so we only have plus sign, and this is approximate 6.9 seconds. This is the answer. So today we discussed about antiderivative. Thanks for listening to this video, and see you next time. Bye bye.